Welcome to Mr. Grid's YouTube channel. Today we're doing Dijkstra's algorithm, finding the shortest path, right? So this is a long worded way of finding the shortest distance. Now, I've already been through this once because I forgot to record, so I'm going to do this a little bit quicker. But looking at this, going from A to F in this network, I could probably work out the shortest path is to go from A to B, B to E, and E to F just by looking at it because it's 2, 2 and 3 rather than 6 and 1, which would be too many, and then 2 and 3, which would be too many, plus another 5 would be too many. So I can kind of eliminate it. So we're aiming to find, realistically, the answer A, B, E, and F. That's what we're looking for. So it kind of helps whilst we're learning this to have that in the background. The first thing that we're going to be doing is we're going to be writing the vertex that we're starting in the first row. So A goes down there, then the rest of the vertices get put along the top. It doesn't matter what order you put these in, as you'll see as we progress. Step 2 says complete the first row. So look at the graph and find the vertices that are directly connected to row A. So if I am at row here, I'm directly connected to B, and I'm directly connected to C. So that's a 2 to B and a 6 to C. So I would write those two numbers down, 2 and 6. And then for the rest of them, I do crosses or dashes because they're not connected to A in any way yet, right? After that step, what we need to do is put a box around the smallest number, and that 2 is going to be the easiest way to get from A to B, right? No matter where we go. So A to B, yeah, quickest way is just to go that 2 across, right? The rest of these numbers we're going to kind of go through in a second, and then the column B for the vertex is now B. What this last sentence means is that B will now stay as 2 for the entire this column, right? We're going to eventually get boxes around letters of each of these numbers. So if I flip over my page, my next step, right, is to work out, so from then B, what is the fastest way to get to C, D, E, and F? Right, so from column B, I'm going to actually do this so it's a little bit, you guys can see that graph there now still. From B to C is 2 kilometers, right? So if I'm going from B to C, it's 2 kilometers. Is that better than going from A to C? Going A to B, then to C. It's 2 and then 2. It's 6 across here, so 4 is better than 2. So it's actually faster to get to C via B, right? So it's a bit quicker. So what I need to do then from B to C, it is quicker to get to C to go via B. So I'm going to do the 2 plus 2, and my new number here is going to be 4. So that 4 is, it's in this next step kind of here, but that 4 is going to go there. Then I need to ask the question from B to D. So this is page 20 for anyone who's following along. I didn't say that out loud. All right, so now we've gone ahead and we've gone, all right, sorry. We need to figure out from B to D. If I'm looking at the graph, B does go directly to D with a thing of 3. So we can count the 2 to there, plus the 3 is going to give us a answer of 5. So we're going to have our 5 down here. The last one is B to E, so our definition's here for you if you need. And we're adding on that 2 from this box because we've got there, right? So we can trial it unless there's a faster method. So B to E, I'm looking back at my graph. B to E is another 2, so there's a 2 plus a 2, which is a 4, right? So that's the fastest way to get to E so far. So that becomes a 4 down here. And then there's no way from B to F. So going from B to F, there is no pathway just there. So once we've got our numbers written out in our list for this next section, we need to choose the next smallest number. Now there's 2 4s. It doesn't actually matter which one you choose first. For the sake of this problem, they've squared off this 4, right? But you could have just as easily done C. So they're doing E next. E goes in here, and now we're going to do all the pathways from E to the rest of them. From E here, right, we probably want to take note that this 2 gets brought down. So like we would draw a little box with a 2, draw a little box with a 4. That would be part of our kind of process. And then we're asking the question from E to C, and we're starting with that 4 number. So E to C, from E to C, there's no new path. Sorry, from E to C, there's no new path. So we just copy down the number that's in there. So that becomes the 4 still. From E to D, go back. E goes down to D and there's a 2. So then we need to ask ourselves the question, is 4 plus 2 better or worse than the 5 that we already can do to get to D? It's worse, so we keep the 5, right? The fastest way to D isn't via E, so it isn't via this one going that way. It's faster to just go there than there. Sorry, it's faster to go there than there rather than go via this node or vertex. The last one is E to F. And in this situation, if we're going E to F, there's a 3. So we can say, all right, well, 3 plus the 4 from our previous step is 7. So that becomes a 7. And we're ending up with a box kind of filled out like that. So that's all worked out here as well. So this is all in the bottom steps here to work out how you get that row. If you're in your bound reference and you're not really sure how you got that row. Right. Moving on, we need to pick another number. So we pick the smallest number here, which is the other 4. So from C, so our next row becomes C, and we fill in the 2, the 4, and the 4. And now we're looking from C to D. Is C to D better than going 4 somewhere? So we're going back here. C to D, it's adding on a 1 to 5. So is that better than what we've got already? We've got a 5, so it's not the same, so we keep it. Then we go C to F is the other one we're looking for. So C to F, there's no new pathway, so that stays as a 7. So now we've got the 5 and the 7, choosing the smallest one, which is going to be our D row. So D goes down to here. Now we're asking ourselves, so boxing off the 5s, the 4s, we're in our last little section. D, the only way to get from D to F is with the 5. 5 plus 5 would be 10, so we're going to keep the original 7 that we've got. Right, and that is our final box. Right, so we've done it. Pretty much gone through and solved it already, which is great. Can you take note that for some silly reason your bound reference, it doesn't say the correct letter here. I think it says E. It's meant to be D, right? Because we went from C to D. So that should be D, and that should be D there. So you need to change those to Ds. It's a spelling error, but will be very confusing if you don't amend it. Crossing that out. Because otherwise you've got 2 E's. If you've got 2 of the same letter, you've done something wrong. Right, so now we're going back and we're kind of going to try and read this graph, right? Now, remembering our desired pathway when we went back here, our desired pathway is A to B to E to F. So I'm just going to kind of note that here. A to B to E to F. A to B to E to F. If what we do is we start here, the arrows are a bit confusing, right? I kind of prefer to do a bit of a highlighting action. So we start at the 7. The 7 says to get from F, the best way to get from F to the next letter on the correct way home is to go to, we slide across to D. F, so we go, so we go up with our F here until the 7 stop. Right, so we stop in our bottom one. That's the one we're trying to solve for. So we go up to the top of that and slide across. The best way to get from F to home is go F to E. So we could write this down in reverse, go F to E. Right, that takes us across to the E column. Right, so we go across to the E column then and up to where the E column ends, which ends in B. So we're going across to B. Right, so we slide all the way across to the B column, and then we're going, all right, well, in B column, well, it says it's going up to, we stop at the A, so we go across to A, so we need that to be written as F all the way up to E, so we go to E all the way up to B, because we're in B, all the way up to A and A. All right, what do you notice about this compared to our answer that we're looking for? Is the backwards. So we need to then rewrite it, right? We need to switch this around so it becomes A to B to E to F. That is Dijkstra's formula. All right, it is long. It is a big process, particularly for smaller graphs. But if you're asked to use the formula to solve a problem or find the shortest path, usually be worth, say, 3 marks. You get a mark for the labeling of things correctly, you get a mark for your formula, and then you get a mark for the answer. So even if you don't know how to do it or you're not confident in drawing out your table, still figure out the shortest path whatever way possible, because if you've got the correct answer, you can still probably pick up a mark.